Alright everyone, it's me, Dr. Smith, in a very loudly air-conditioned room. We're going to do some practice problems for energy and momentum and all that crap. So, these are the problems that I wrote. I will be doing a separate set for Mr. Rose's problems. So, Luke Skywalker here in problem 1 is engaged in a lightsaber duel with his father when he stumbles into a carbon freezing pit. And he has to jump straight upwards to grab these exposed utility cables. He can jump 10 meters per second upward. Neglecting air resistance, will his jump carry him high enough to grab the cables and escape the cryogenic gases in the pit? This is, of course, from The Empire Strikes Back, the second of the Star Wars movies. So let me just draw a little diagram of the problem here. So Luke has fallen into a carbon freezing pit. Oh no! And there's Luke down at the bottom, and Luke is like extending his hands upwards as he starts to jump. So, and he has to jump up and get some cables that are 5 meters above his hands. So, there, and that's 5 meters, and the cables are up here, you know, hanging cables, whatever. Okay. Meanwhile, over here, of course, is Darth Vader, you know, who looks like this. And, right, and then Darth Vader has a cape on, of course, and he's wielding his lightsaber, which is red. Okay. And his face is black. And anyway, okay, so that's enough. That's enough drawing. Okay, so we got two states of the problem. One is the first state is when Luke is just left the ground with his velocity going straight upwards, equals 10 meters per second, straight up. And then the second is when Luke has sort of hypothetically grabbed the cables and he's up here. And this is stage 2. So, what we want to find is whether there's enough energy, or whether Luke has enough energy to make it up. Because energy is rising, has to gain some gravitational potential energy, which means he needs enough kinetic energy to, you know, pour into the gravitational potential energy to get there. So, let's start with point 1, where his kinetic energy is 1/2 m times his initial velocity squared. And his potential energy, due to gravity, is going to be, we're going to find that as the point where we have 0 potential energy. So right here, this is our point where UG equals 0. Okay, so total mechanical energy here is 1/2 mv0 squared. At stage 2, or, you know, state 2 really, he has some kinetic energy. If he makes it, he might have some kinetic energy left over. We don't know. We hope this is greater than 0, but we don't know, or at least 0. His potential energy here is going to be mgh. So h is how far he's come up, which is h times 5 meters. H is 5 meters. And then so emech is ek final plus mgh. So what we do here is we set these two mechanical energies equal to each other. We're going to ignore the non-conservative forces here. So this is our initial mechanical energy, 1/2 mv0 squared. And we're going to see if Luke, in fact, has positive kinetic energy. What we really want to see is if this 1/2 mv0 squared term is bigger than this mgh term. So you can think of this as the energy he needs to save himself. And this is the energy he actually has. And this is the extra, and we hope this extra is positive, because if negative, Luke is screwed. It means he doesn't reach the cables. So, now we can go ahead and say this final kinetic energy is 1/2 mv final squared, okay? So, because when we do that, so that's just this term here is 1/2 mv final squared. Because when we do that, we can cancel out the m's, and in fact we can, yeah, so then we can say v0 squared over 2 equals v final squared over 2 plus gh. And so, I don't know, let's see. Let's say v final squared equals v0 squared minus 2gh. And so what we're going to do is we're going to plug all this in. If this is positive, then v final squared is positive, which means v final is a real number. So that means he actually can reach the cables here. If we get a negative number for v final squared, that means that v final would have to be imaginary, and that means that Luke can only escape in our imagination. So, let's go ahead and plug this in. v0 squared, this was 10 meters per second, squared minus 2 times 10 meters per second squared, we're using for g, times, well, times 5 meters, which is the height. So this is going to equal 100 meters squared per second squared minus, over here, 100, and it's going to come out to be meters squared per second squared. So if we use 10 for g, then Luke makes it just exactly up to the cables, at which point he has no kinetic energy left, but he just barely makes it. So there you go. And I think if you saw the movie, Luke actually shot up a good bit faster than that. So this is not strictly accurate. But what we can say here based on this is that Luke did escape. And if we use 9.8 for g, then this number here, this would be 9.8 instead of 10. This would be a little smaller, so Luke would actually even have like a couple of, like a tiny little bit of extra energy. So he would actually have a little speed when he reaches the cables and have, a little room to spare. But anyway, there's your solution to that problem.